Hi everyone, welcome again to my YouTube channel. So in this particular video, we're gonna be talking about memory management in the Spark from interview point of view. But before we start, we will be covering theory a bit so that we have the base of what kind of questions will be asked and how to answer them. But before we start the video, I want to share one very important point which I felt in last 3-4 days. So last 3-4 days has been very hard on my life. I was very ill, not able to you know do anything properly. And this video was supposed to be, the content was created 3 days back, but still I was not able to video because I didn't have any energy. So one thing I realized, which I want to share with you guys, we take our health for granted, and which means that okay, we don't care about it. We just think that okay, everything is good. But once we are ill or once we are sick, then we realize that how important health is. How important, how it can impact our quality of life, how it can, if we are not into our good shape, how it will impact our abilities and opportunities, right? How it will increase the stress on ourselves. That's why taking good care of our health should be our top priority, which means we should live a healthy lifestyle. We should be eating a balanced diet. We should do regular exercise. Manage your stress properly. Spend time with your loved ones. That's the most important part, and that's what I realized in last 3 days. Only one who really care about you are your family members. So please give time to them. Stay in touch with them. That's all. I know this is nothing related to this topic, but this just came out of mind, and I wanted to share with you guys. Anyways, let's start the topic now. So when we talk about Spark memory management in Spark is a crucial aspect of the performance and stability of a Spark application. So memory management is not only applicable for Spark application, any processing application, any application, memory management is a key. So Spark uses combination of memory management techniques, including in-memory caching, off-memory, disk spills, to ensure that memory requirements of a Spark application are met. The following are the key aspect of memory management. So memory management includes memory allocation. So how Spark is allocating memory to different components such as executor, driver, and caching. So memory allocation is based on different configuration setting. For example, how much memory should be assigned to each executor, and the fraction of memory reserved for caching. We will be covering it, but yeah, memory usage optimization. So Spark optimizes the use of the memory by storing the data in the most efficient format possible. These include in-memory columnar storage, data serialization, data compression. Third is caching. So caching, we already know Spark support caching of intermediate results, right? The fourth one is important, off-heap memory, which we usually forget. So Spark supports off-heap memory, which allows for the efficient storage of large data structure without the overhead of garbage collection. So this point is important, and I will be covering this many times in this interview series. So for off-heap memory, obviously off-heap means which is outside the JVM. So see, Spark Executor. So let me try to draw it here. So this is your Spark Executor, right? So what Spark Executor is, this is Spark Executor. So in reality, this is just a JVM. So when we talk about JVM has its own memory, right? So some memory is allocated to it. So this memory is part of JVM. So there, obviously, this JVM is part of the bigger machine, right? And there is more memory here. So this memory is called on heap, which is on a Spark JVM machine, and this is called off heap. Since this JVM is not managing this memory, so the garbage collection of this memory is not needed. It's as simple as that, right? I'm not sure why people are making this so complicated. So if the memory is not controlled by JVM, it is off heap. If it is controlled by JVM, it is on heap. And the garbage, obviously, if it is controlling it, it will control every aspect of it. Simple. Now the fifth thing is disk spill. So Spark supports disk spill, which allows for the overflow of the data from memory to disk. Garbage collection. So every JVM has a garbage collector to manage memory. The garbage collector runs periodically to reclaim a memory that is no longer in use for the application. And the final one is the executor memory, which obviously everyone loves it. Everyone have heard it multiple times. So Executor and Sparks are responsible for executing tasks and storing intermediate results. The memory usage of the executor is determined by the configuration setting and size of the data processed, right? So now let's jump to Spark memory management. And so we haven't covered any interview question yet, right? So let's jump to more theory. It's important again. So Spark is an in-memory processing engine where all the computation that takes place does happen in memory. So it is important to understand Spark memory management, right? So if the memory collection allocation is too large when committing, it will occupy resources. If it is too small, memory overflow and full GC problem will occur easily. How Spark architecture looks like: we have a driver program, right? We have cluster manager, we already know this thing, and then we have worker nodes. So in worker nodes we have executor. This executor will have their own memory, right? So driver program is the main control of the program, which will be responsible for creating a Spark session context, submitting the job, converting the job to task, coordinating tasks between the executor. Executor is the main thing, mainly responsible for performing this specific calculation and returning the result to the driver, right? So driver memory management is relatively simple because it's just one entity. Spark does not make a specific plan for that. So the only important thing what we caring about here is the executive memory management. Why? Because executive memory management in Spark is a complicated topic, and that we will see. There are two types of memory, right? Off heap, on heap, which we already covered. So memory management in Spark is basically of two types: static memory management and unified memory management. Since Spark 1.6, unified memory management has been set as default manager for Spark. Static memory management has been deprecated because of lack of flexibility. Obviously, if we are just allocating some memory to storage, some memory to processing, fixed, it doesn't make sense, because if processing is not taking place, it might not be applicable for the storage, and vice versa. There is only one memory in per JVM, and that's called unified memory, right? Now let's go for UMM. Since Spark 1.6, we have a new memory management that is adopted to replace static memory manager, to replace with dynamic memory allocation. It allocates region of memory as a unified memory container that is shared for storage and execution both. When execution memory is not used, storage memory can acquire all the available memory and vice versa. If any of the storage execution memory needs more space, a function called acquire memory will expand one of the memory pool and shrink the another one. Borrowed storage can be evicted at any time. Borrowed execution memory, however, will not be evicted in the first design due to complexity and implementation. Now, this is important, and I'll explain it in again 1 minute. So you have two memories, execution and storage. So what they are saying, that if you want more storage memory and no execution is taking place, you can have it. So in this way, so this is your unified memory, and this memory is divided into storage and execution. So let's say execution is not taking place, so storage memory can take this memory as well. But let's say if you submit a job and it wants some execution, what it can do, it can reclaim this memory again for execution. Okay, so this is one scenario. But let's say we have another scenario like this. We have storage, execution, right? And let's say storage is filtered here, and execution happened. Execution, you submitted a job and it needs more execution memory, and let's say we reclaim this memory for execution, this one, and afterwards you want more memory for storage. This reclaim, this memory which has been allocated for the execution, won't be reclaimed by storage because it will be complicated. That's what it is written here. To reclaim storage memory is complicated, but to reclaim to reclaim execution memory is complicated, but to reclaim storage memory is simple. And it makes sense. If there are multiple tasks executing, it has some memory allocated to it. How we gonna be replacing them? Which memory we gonna be allocating? So Spark creators think in a simple direction that okay, if we have somehow claimed the storage memory for some time, let it be, right? Okay. So what are the advantages of this? The boundary between storage memory and execution memory is not static. In case of memory pressure, the boundary would move. One region would grow by borrowing space from another one. When application has no cache, execution use all the memory to avoid unnecessary disk flows. When execution has cache, it will reserve the minimum storage. The approach provides reasonable out-of-the-box performance for a variety of workloads without requiring user expertise on how memory is divided. Okay, so let's see. So this is again, so as we discussed, we have JVM, and JVM has two types of memory: on-heap memory and off-heap memory. Let's discuss on-heap memory in details. So basically, Spark uses on-heap memory only, right? Because obviously Spark runs on JVM, and JVM has its own memory, and it can only use that memory for some time. I'm not saying that we cannot use off heap, but let's focus on heap now. The main how to allocate this on heap memory, and we have heard about this particular parameter. To allocate on heap memory to Spark executor, we're gonna be using spark.executor.memory. We have used this a lot of time, or we can use executor memory as well, any of these parameter, right? Okay, so now we have allocated some memory using spark.executor to memory. Now this memory, out of this memory, how much memory will be allocated for your storage and how much memory will be allocated for your execution will be divided by a parameter called spark.memory.fraction. So by this parameter, fraction of the heap space used for execution and storage. So lower this is, the more frequency of spills and data eviction from the cache will take occur. The purpose of this config is to set aside memory for internal metadata, user data structures, and imprecise size estimation in case of sparse and usually large records. Other most important parameters is spark.memory.storage fraction. This is the size of the storage region which within the space set aside by the storage spark.memory.fraction. Okay, so cache data may only be evicted if total storage exceeds this region. So now let's see this diagram. So this is your whole JVM, right? This is your whole JVM. In this JVM, we have allocated our Spark memory using which parameter? Spark. So basically spark.executor memory. Let's say we defaulted to 1 gig. In this 1 gig of memory, we have Spark memory, we have user memory, and we have reset memory. Let's see what all these are, right? And these all will make up your usable memory. So usable memory means every memory of Java heap except the reserved memory. So let's see what reserved memory is. So reserved memory is the memory reserved for the system and is used for the Spark internal objects. We'll keep it simple. One important setting is spark.testing.reserved memory. It is, the reserved memory size is hard-coded and it cannot be changed in a way without Spark recompilation. And this setting can be used, but it's not recommended, right? The formula for the reserved memory is, so it somewhere around, let's say we have, if the executed memory is less than 1.5 time of reserved memory, for example this, then reserved memory will be, the Spark job will fail with the following execution message, right? So we, in simple case, we won't touch it. Let the reserved memory be obtained by itself. Now coming to the user memory, So user memory is the memory used for to store the user defined data structures, Spark internal metadata, UDFs, etc. So the formula will be what? Java heap minus reserve memory into 1.0 Spark memory fraction. So this will be your user memory, right? And the third one is your where is that? So we have covered Spark memory, or this one. So yeah, this is just beyond it. So I'll highlight it so that we won't miss it. So final one is Spark memory. So Spark memory is a memory pool managed by Apache Spark. Memory is responsible for storing intermediate state while doing task execution like joins or storing broadcast variables, right? And this is controlled by this parameter, right? So boundary between them is set by spark.memory to storage fraction parameter. By default it is 0.5. This memory is used for both execution and storage. So execution means what? Execution means if we want to go for shuffle, joins, sort, and aggregation, storage can be used for cache partition of the data. So this is theory. So this is very high level theory. If you want to jump deeper, we can go for another 1 hour just on this, right? Let's do one thing and see. This is a great article which I will share the link here. Yeah, so this is the article from Cloudera community. I will paste this link into the description. Please go through it. It's a great article, right? So most important questions now. So let's jump to questions. So we know some bit about JVM, Java heap, op heap, user memory, result memory, and number of things, right? But this question will be asked in interview. Most important question is what are the reasons of out of memory issues in Spark? So the first important reason is data skew. Second is garbage collection. Third is if you have not configured it properly, like if you have not configured this executive memory, driver memory, or Spark buffer size properly, then it will run out of the memory. If you have UDFs, which UDF can cause memory pressure if they return inefficiently, if they're writing data inefficiently, or if they store too much data in memory. There can be network error, there can be caching, because if you're caching too much, there will be issue, right? Shuffling operation. So Spark shuffle operation, which repartition the data processing, can cause high memory usage. Memory garbage collection, optimizing. Okay, so now how to avoid this, right? So you can, one of the most important thing is monitoring garbage collection. You can optimize your UDFs, you can optimize data skewness, you can bound the iteration. It means implementing the strategies to limit the number of iteration, and iterative algorithm can reduce the memory usage of out of memory error, right? Okay, what are, and again I have again highlighted it, what are most important parameters related to memory management in Spark, right? There are 4 parameters which I think we already covered, but let's go through it. Spark.executor.memory. So this sets the total amount of memory on each executor. Spark.driver.memory. This sets the amount of memory that driver can use. Spark.memory.fraction. This set the fraction of total executor memory can be used for the caching of RDD and broadcast variable. Spark.memory.storage fraction. This sets the total executor memory that can be used for storage as opposed to execution. So these are important parameter. So I think we have covered. So okay, if we talk about some practical examples, if somebody asks you what are some of the practical example of OOM or out of memory issues in Spark and how to address them. So Spark here, the one of the most important reason is insufficient executive memory. So if there is less execution memory, there will be out of the memory issue. You can increase the executive memory by Spark executive memory configuration. Large shuffle operation if there, obviously there will be execution memory shortage, and it will give out of memory error. If data has been grown exponentially, if you have an application that reads data and caches it, and you need to make sure the data size is not growing unbounded, as it can cause out of memory issues. Serialization overhead. So Spark uses Java serializer by default, which can be slow and use large amount of memory. UDFs I have already explained, poorly optimized algorithm, which is very common across and any processing system. Okay. Now, if somebody asks you what are some of the real world examples, right? So let's talk about financial industry. So if let's say if you have a Spark job running and which is processing large amount of financial data, the out of memory error in this scenario can be due to limited memory of a Spark executor. To resolve this data can be partitioned and processed in smaller chunks to reduce memory process. Most of the time, if out of memory error is coming, the easiest way is to redistribute the data, process in smaller chunk. But before that, have a look why data is high, why data is skewed, or why data is not processing in smaller chunks or in smaller partitions. When we talk about, let's say, healthcare industry, so Spark job was processing, this is an example what we can give. Spark job was processing medical records, images, leading to out of memory error due to high memory requirement of image processing. To resolve this, images were pre-processed and stored in distributed file system, reducing the memory requirement of Spark job. One of the example from e-commerce industry can be Spark job was processing customer purchase data and creating recommendation, leading to the out of memory error due to large amount of data. To resolve this, data was aggregated, pre-processed to reduce the memory requirement. So we can give multiple examples, right? Now these are the questions what we're going to be covering in now. There are 50 questions which we will discuss. So the first question is, can you explain the role of a Spark executor memory and how it is used in a Spark application? So Spark executor memory refers to the amount of memory that is allocated in each executor, allocated to each executor process in a Spark application. Executor memory is used to store the data that is processed by the task running on the executor. This includes intermediate data generated during transformation, shuffled data during shuffles, cache data, and IDD persistence. How does Spark handle memory spill to disk? And when the memory of an executor runs out? When the memory of executor runs out of Spark data, Spark will spill the data that cannot fit in the memory to the disk. The process is called spilling and occurs when executor runs out of the memory and needs to free up space for the new data. The data that is spilled on the disk is read back into the memory as needed, allowing the executor to continue processing the data. Spark will spill the data to disk as a last resort. This process can slow down the performance of application, right? But the cool part is, if you want to process 10 gigs of data, you have only 1 gig of memory, still you can do it. There will be spilling, but yeah, it will slow down the process, right? What is the relationship between Spark executive memory, RDD partition size, and amount of memory available in the cluster? Important question. I'll highlight it. Okay, so Spark executive memory, RDD partition size, and amount of available memory are all interrelated and affect each other. Executive memory determines the amount of data that can be processed in memory in single executor. RDD partition size determines the amount of data that is processed by each task. If RDD partition size is too large, it can lead to high memory footprint and may cause out of memory error, right? On the other hand, if partition size is too small, it can lead to high number of tasks and decreased performance. The amount of available memory in the cluster determines the total amount of memory available in the Spark to use. Can you explain the difference between Spark storage memory and execution memory? We have covered it, but let's quickly read it. Spark storage memory refers to the memory used to store RDDs that have been cached or persisted. The data stored in the storage memory can be reused across multiple stages in a Spark application, allowing for the faster processing time. What is executive memory? What is executor memory? it is the memory used to perform task to perform its processing. Spark memory is used to store intermediate results, uh, uh, for example, shuffle data. Unlike storage memory, execution memory is not reused across multiple stages. So it means it's once used for one processing only, right? Because obviously process cannot be shared across multiple stages. Um, how does Spark uses off heap memory in its operation, and how is it different from on heap memory? Off heap memory in Spark refers to the memory that is allocated outside the Java heap. This memory is used to store data that will be otherwise consume too much space on the Java heap, such as large RDDs. That has been persisted. By using off heap memory, Spark can avoid the overhead of garbage collection in the Java heap and can improve the performance. On heap memory, on the other hand, refers to the memory that is in the Java heap. This memory is used by the Spark to store the data that has been actively processed by the task. Okay, how does Spark handle memory allocation for the shuffle data or the reduce operation? Um, Reduce operation, Spark needs to allocate memory to store shuffle data that is generated during shuffle process. The amount of memory required for the shuffle data depends on the size of the data being shuffled and number of partitions being used. Spark will attempt to allocate enough memory to store the shuffle data in memory, which can significantly improve the performance compared to spilling to the disk. If there's not enough storage memory available, Spark will spill the shuffle data, which can cause the negative performance, right? So this is not related to reduce operation. It can be related to any operation which cause shuffling operation, right? So this is the important question again as well. How does configuration of Spark memory management, such as executor memory, driver memory, impact the performance of application? So the configuration of a Spark memory management, such as executive memory, driver memory, has a direct impact on the performance. Executive memory property determine the amount of memory allocated to each executor, and setting it too low can cause executor to run out of the memory and spill data disk, which will slow down the performance. Driver memory property determine the amount of memory that is allocated to the driver, and setting it too low can cause driver to run out of the memory and crash, right? So important thing, fine tune it. How do you tune the Spark memory configuration to balance performance and resource utilization? Tuning a Spark memory configuration, finding the right balance between performance and resource utilization. To start, it is important to understand the memory requirement of your Spark application. First point, including the amount of data that will be processed, number of tasks that will be run, amount of memory required for intermediate data and shuffle data. Based on this information, you can set executor memory and driver memory properties, ensure that enough memory is available for Spark to run efficiently. Okay, can you discuss the benefits and limitation of using cache method in Spark to persist RDD in memory? Okay, so cache method is in Spark allow you to persist RDD in memory, right? It can significantly improve the performance of Spark application. Benefit of using cache method include improved performance, as cache RDD are available to reuse on multiple stages, reducing the time and computation required to process the data. Additionally, caching RDDs in memory can reduce the time and resources required for the garbage collection. However, there are some limitation of cache method. One of the main limitation is that it requires a significant amount of memory to store RDD in memory, which can lead to increased memory pressure and reduce the available memory for the other Spark tasks. Additionally, caching can also lead for increased disk input output if data needs to be spilled to the disk due to memory constraints. How does Spark handle memory deallocation, garbage collection, to ensure efficient use of cluster resources? So Spark uses sophisticated memory management system to handle memory deallocation and garbage collection, which is designed to ensure the efficient use of cluster resources. Spark uses a lazy evaluation approach. So I'll highlight it. Okay, so this is lazy evaluation approach, which where the intermediate data is not computed until it is needed. So it means once the action is not hit, it won't be computed, which allows Spark to release the memory as and other objects are no longer needed and can be delocated, right? So basically, where so Spark uses a lazy evaluation approach where the intermediate data is not computed until it's not needed, which allows Spark to release memory as soon as it's no longer needed. Additionally, Spark employs a sophisticated garbage collection algorithm that uses a reference counting to determine RDD and other objects that are no longer needed can be safely delocated, right? Uh, can you explain the concept serialization in Spark and impact of memory usage? So serialization in Spark refers to the process of converting complex data structures into compact binary format that can be transmitted over a network and stored on a disk. So this is called serialization, converting data structures into binary format so that they can be transmitted to over the network, right? Serialization is a critical component in Spark because obviously data is when shuffling takes place, when data is moved here and there, serialization needed. The impact of serialization on memory is Spark depends on serialization format and size of data being serialized. In general, serialization format that produce smaller binary representation of the data will consume less memory than the format that produces larger representation. However, trade-off is that smaller binary representation may take longer to serialize and deserialize, which will again have impact on the overall performance of Spark application. How does Spark handle memory intensive operation, group by key, reduce by key? We have covered it in the past using one of the question. It's same. Can you discuss the role of broadcast variables in Spark and impact of memory usage? I think we have covered it, but let's see quickly. Broadcast variables in Spark are read-only variables that are efficiently broadcasted to all the nodes in the cluster, reducing the amount of data that needs to be transmitted over the network. This can have significant impact on the performance of Spark application, especially when processing large amount of data. The impact of broadcast variable on memory usage in Spark depends on the size of the broadcast variable and the number of nodes in the cluster. In general, the impact of broadcast variable, it depends consumed a fixed amount of memory on each node, which can add up quickly if the broadcast variable is large, if there are so many nodes. How does Spark handle memory management when running a multi-tenant cluster? Same. When running a multi-tenant cluster, Spark provides a number of features for managing memory, such as setting memory quotas for individual tenants, as well as configuring behavior of the cluster scheduler to ensure that all the tenants are allocated. So this is important, this particular line, set memory quotas and setting the behavior for the cluster schedule, right? How does Spark manages memory when processing data exceeds the available memory? We have covered it. It will spill on the disk, right? How does Spark handle the memory across multiple stages of a Spark application, and how it manages between stages? Let's see it. Spark handles the use of memory across multiple stages in Spark application by using a combination of in-memory stage, disk storage, serialization. Each stage in a Spark application may have different memory requirement. The Spark memory manager is responsible for managing the allocation of memory between different stages. Can you discuss the impact of data partitioning on Spark memory usage and how it's optimized? So data partitioning in Spark have a significant impact of memory usage. When data is partitioned, it is divided into smaller chunks and can be processed in parallel. The number of partition can affect the memory usage as each partition requires some amount of memory to store. The size of partition also affects the memory usage, right? As larger partition require more memory. To optimize data partitioning for memory usage, it's best to use the partition size that is small enough to fit in the memory, right? Important. How does Spark handles memory offheap? We have covered it. Can you discuss the impact of UDFs on memory usage? This is interesting, so the use of UDF in Spark can have impact on memory usage, as UDF can be memory intensive sometimes and cause application to run out of the memory. The impact of UDF on memory usage can be mitigated by reducing the amount of data processed by each UDF, optimizing the UDF code for memory usage, using a Spark broadcast variable, etc. Okay, how does Spark handles memory management when executing machine learning algorithm? I think it's more or less same. So it will be combination of in-memory storage, disk storage, serialization, what we have covered, right? Memory leaks in Spark can have significant impact on the performance and stability of application. Okay, let's talk about memory leaks. So if somebody asks you what memory leaks are and how they will impact the performance. So memory leaks in Spark can have significant impact on the performance and stability of a Spark application. These leaks can occur when a Spark objects or data structures hold onto references to the data objects that no longer needed. To identify memory leaks, it's important to monitor memory usage of Spark application, track memory usage over time, and analyze heap dumps to identify the root cause of leak. To address memory leaks, it's important to properly manage references of Spark objects and data structures. Avoid holding on to unnecessary references, use caching and persist method judiciously to ensure that memory is only used for the necessary objects. How memory used in Spark streaming application? So in Spark streaming application, memory management is especially important as data is processed in real time and continuously. To handle memory management, Spark streaming uses a sliding window approach, where the data is processed in batches and memory usage is controlled by setting the window size and batch interval, right? Okay, so now let's see the size of the data processed in Spark can have significant impact on data memory usage. To optimize the memory usage, it is important to use data partitioning, data compression, data serialization efficiently. So I think again and again I'm covering one point here. This one. Data partitioning, data compression, data serialization are very important when we talk about memory usage, right? Spark Shuffle is responsible for shuffling data between Executor and Spark application. It plays a crucial role in Spark application, but again in memory, it is memory highly intensive application, highly intensive on memory usage, right? How SQL queries are executed and how they are related, how the memory management is managed in SQL queries. So when executing SQL queries, memory management is critical to ensure that the performance and stability of application. Spark SQL uses a combination of in-memory, disk storage, caching to manage the intermediate results. The configuration of this storage can be impact the usage and performance of the Spark application, right? How custom partitioning will impact the memory usage? By custom partitioning, data can be organized and distributed in a way that optimizes the memory usage and reduces the overhead. Because obviously we as a user are deciding that custom partitioning. So it means custom partitioning most of the time, if you are doing it judiciously, it will benefit you, right? How number of executors and the memory configuration will impact the performance? I'm reading this question. So number of executor memory is used to store the data processed by the Spark application. Having more executor with higher number of configuration can allow the application to process more data in parallel and improve performance. However, too many executor will have higher memory configuration can result in resource contention and negatively impact the performance. You know, that's why it's very important to have number of executor and their memory configuration by researching, by trying in and out, right? Let me quickly see. Okay, let's see the garbage collection one. So what is the importance of garbage collection, how it's done, right? So garbage collector configuration can have significant impact on Spark memory usage and performance. Spark relies on Java garbage collector to manage memory used by application. Configuration of the garbage collector can reduce the amount of time on the garbage collection. Okay, can you discuss the role of data serialization and the overall? Okay, this is important. I have explained it in detail. Let's see. So can you discuss the role of data serialization in the overall performance Spark application and various strategies in optimizing serialization in Spark? So memory management is a critical aspect. We have seen it. Serialization plays a key role in overall performance in a Spark application as it determines how data is stored and transmitted between nodes in a cluster. The choice of serialization can have a significant impact on the memory usage and performance. For example, using a more efficient serialization format can reduce the memory overhead and improve the data transfer speed, while the less efficient format can lead to increased memory usage, right? So the memory management when executing iterative algorithms such as gradient descent, metric factorization is also critical for performance of the Spark application. So when we summarize, effective memory management, the overall performance, effective memory management is very important for the overall performance of the Spark application. And choice of serialization, data size, data distribution, use of caching, all are the factors of the Spark memory performance, right? Um, okay, so let's see. Just okay, let's go to this question. Okay, so what is serialization? And let's cover serialization, right? Um, let's cover serialization and then we'll jump to the final few questions. So serialization we know. So Spark serialization when we want to transfer the data in the node to the cluster, right? So I think we have covered it, right? But serialization and deserialization, two important things, and both are memory intensive. So once we uh, choose a serialization, for example, Java, Cryo, whatever we want to choose it carefully. It depends on how and do it tried and then implement it. Broadcast variable we have covered, memory management we have covered. Uh, can you explain how Spark manages memory in its operation? Okay, so let's see it. Spark uses a lazy evolution method, which means the transformation are not executed immediately, but instead compiled in a DAC, direct acyclic graph of the transformation. This DAC is executed when action is triggered. This approach helps to optimize the memory usage by reducing the amount of intermediate data structures needed to store the data. So Spark also has a tiered storage model. This is important, new for a lot of folks, where data can be stored in memory and disk. The storage level of the data structure can be controlled using caching and unpersisting operation, right? How does Spark serialization? Serialization is important, guys. I'm telling you, right? So that's why the question is again and again. Can you discuss the impact of group by key? We have covered it. How does Spark management of memory? We have covered it. Can you discuss the impact of caching? We have covered it. Can you explain how Spark partitions data and the operation? Can you explain how Spark partition data? Okay, so Spark partition data in its operation by allowing parallel processing across multiple nodes in the cluster. When data is partitioned, it is divided into smaller manageable chunks called partition, and each of these can be processed on a separate node. Shuffling we have covered. Can you discuss the impact of size of RDD on the Spark performance? We have covered it, I think. If the size of the RDD is large, the task will be large, partition will be, so it all depends, there should be, so let's read it, right? Larger partition can lead to increase input output, increased memory usage, while small partition can lead to increased overhead from the managing the partition structure. So it means you need to have a let's say 128 MB size or something, right? What else? I think I have a very, can you discuss different type of joins? That's not needed. Can you explain the concept of RDDs? Not needed in this part, that we will cover later. There was one last question. Okay, so I think that's all. So see, when we talk about Spark memory management, so we talked about few things, right? So we talked about unified memory, we talked about Spark executor memory, driver memory, how to allocate them, what are the Spark memory fraction, what are different operation which will impact the performance, how Spark manages different operations, how deserialization, serialization impact the performance. So from memory management point of view, I think we have covered everything from top down to bottom up. If anybody asks you anything, nothing will come out of here. That's for sure. So do go through these notes, these videos again and again, and we'll meet again in next video. And next video, I think we will be covering cluster management. Somebody asked me to cover checkpointing as well. So I can make a video on checkpointing, but it won't be a long video. Checkpointing is not as large topic as these memory management, cluster management, all right. So we gonna be talking about all this. So guys, let's do one thing. If you want uh, me to make a video on some specific thing, please don't hesitate. I am more than happy to create a video, but please do comment, do subscribe, and like and share the video. Thanks a lot.